Jai Hind to everyone. My name is MILI SRIVASTAVA and today I am going to discuss about big data in cloud computing, cloud technologies and advancement. So, what is big data? The quality of data on the planet Earth is growing exponentially for many reasons. Various sources and our day-to-day activities generate lots of data. With invent of the web, the whole world has gone online. Every single thing we do leaves a digital trace. With the smart objects going online the data growth rate has also increased rapidly. The major sources of big data are social media sites, sensor networks, digital images, videos, cell phones, purchases, transaction records, weblogs, medical records, archives, military surveillance, e-commerce, complex scientific research and so on. By 2020, the data volume will be around 40 zettabytes, which is equivalent to adding every single grain of sand on the planet multiplied by 75. So, what is big data? Big data is basically big data is a term used for a collection of data sets that are large and complex, which is difficult to store and process using available database management tools or traditional data. Big data is the term for a collection of data sets so large and complex that is become difficult to process using on-hand database management system tools. There are so many processing applications. The challenges includes capturing, curating, storing, searching, sharing, transferring, analyzing and visualizing of this data. So, this is the introduction of big data. The challenges include capture, curation, storage, search, sharing, transfer, analysis and visualization. This is the diagram of what is big data. Big data, with the help of this graph, we can easily understand how quantity of big data grows day by day exponentially. Basically, there are three characteristics. The challenges including capturing, curating, storing, searching, sharing, transferring, analyzing and visualization of this data. So, basically there are some characteristics of big data. There are 5 characteristics that define big data are volume, velocity, variety, veracity and volume. This is the diagram of volume scale, how big data volume increases day by day. Data volume is increasing, 44x increasing for 2009 to 2020 from 0.8 zettabytes to 35 zettabytes. We can easily see how exponentially it grows day by day. So, what is volume? So, what is volume? Volume refers to the amount of data, basically what amount of data which is growing day by day at a very fast pace. The size of data generated by humans, machines and their interactions on social media itself is massive. Researchers have predicted that 40 zettabytes, that is 40,000 exabytes will be generated by 2020, which is an increase of 300 times from 2005. This is as I already discussed, this is the graph by which we can easily compare how big data, how the quantity of data increased day by day. Now, this is some forms of big data, like there are so many data and we get that data from Facebook, Google Drives, particular business websites. There are so many exposures by which in which we can store our data in system. Next is variety. What is variety? As there are many sources which are contributing to big data, the type of data they are generating is different. It can be structured, semi-structured or unstructured. Hence, there is a variety of data which is getting generated every day. Earlier, we used to get the data from Excel and databases. Now, the data are coming in the form of images, audios, videos, sensor data, etc. as shown in this figure. So, hence, this variety of unstructured data creates problems in capturing, storage, mining and applying the data. We can get data from relational database, text data, semi-structured data, graph data, streaming data. A single application can be collecting many types of data. Big public data online, weather, finance, etc. This is a single view to the customer. As a customer, they can get data from so many websites like Facebook, Twitter, Pinterest, Zigna. There are so many websites, Netflix. In our daily life, we can store our data from variety of places. Next is velocity. What is velocity? Velocity is defined as the pace at which different sources generated the data every day. This flow of data is massive and continuous. There is 1.03 billion daily active users, that is for Facebook on mobile as of now, which is an increase of 22% year over year. This shows how fast the numbers of users are growing on social media and how fast the data is getting generated daily. If you are able to handle the velocity, you will be able to generate insights and take decisions based on real-time data. So, this is the velocity of data. Data is generated fast and need to be processed fast. Online data analytics, late decision, missing opportunities. Examples: e-promotions, healthcare monitoring. This is real-time fast data. The progress and innovation is no longer hindered by the ability to collect data, but by the ability to manage, analyze, summarize, visualize and discover knowledge from the collected data in a timely manner and in a scalable fashion. Some make it 4 V's: volume, velocity, variety and veracity. Next, we can discuss about volume, velocity, variety. Now, veracity. What is veracity? Veracity refers to the data in doubt or uncertainty of data available due to data inconsistency and incompleteness. In the image, you can see that few values are missing in the table. Also, a few values are hard to accept. For example, 15,000 minimum values in third rows. It is not possible. This inconsistency and incompleteness is veracity. Data available can sometimes get messy and may be difficult to trust. With many forms of big data, quality and accuracy are difficult to control, like Twitter posts with hashtags, abbreviations, typos and colloquial speech. The volume is often the reason behind for the lack of quality and accuracy in the data. Due to uncertainty of data, 1 in 3 business leaders don't trust the information they use to make decisions. It was found in a survey that 27% of respondents were unsure of how much of their data was inaccurate. Uh, Poor data quality cost the US economy around $3.1 trillion a year. It was found that there are 27% of the respondents were unsure of how much of their data was inaccurate. So, this is the veracity. So, some make it 4 V's: volume, velocity, variety and veracity. Volume, data at rest, data in motion, terabytes to exabytes of existing data process. In the case of velocity, data in motion, streaming data, milliseconds to second to response. In the case of variety, data in many forms. Data from where we get data, there are so many sources we can get our data structured, that is this is maybe structured, this is unstructured, text and multimedia. And in the case of veracity, data in doubt, uncertainty, because of uncertainty veracity occurs. So basically there are 4 V's in big data. Next is classification of big data. So basically we classified big data into 3 parts, that is, first one is structured, second is semi-structured and third is unstructured. So what is structured data? In the case of structured data, the data can be stored and processed in a fixed format is called as structured data. Data stored in relational database management system is one of the example of structured data. It is easy to process structured data as it has a fixed schema. Structured query language is often used to manage such kind of data. After it is all well and good to have access to big data, but unless we can turn it into a value, it is useless. By turning it into value, I mean, is it adding to the benefits of organization who are analyzing big data? Is the organization working on big data achieving high return on investment? Unless it adds to their profits by working on big data, it is useless. So this is the first form of big classification of big data. This is structured. Next is semi-structured. Semi-structured data is a type of data which does not have a formal structure of a data model, that is, a table definition in a relational database management system, but nevertheless it has some organizational properties like tags or other markers to separate semantic elements that make it easier to analyze. XML files or JSON documents are examples of semi-structured data. So in the case of semi-structured data, we can say that data available can sometimes get messy and may be difficult to trust. We due to uncertainty of data, one in three business leaders don't trust the information, and we can also excluded that in the terms used for collection of data sets that are large and complex, which is difficult to store and process using available database management system tools or traditional data processing applications. Next is unstructured data next type is unstructured data. So in the case of unstructured data, the data which have unknown form and cannot be stored in RDBMS and cannot be analyzed unless it is transformed into a structured format is called unstructured data. Text files and multimedia contents like images, audios, videos are example of unstructured data. Thus, unstructured data is growing quicker than others. Expert says that 80% of the data in an organization are unstructured. Till now, I have just covered the introduction of big data. Furthermore, the big data characteristics, examples, applications and challenges and big data. So, in the case of big data, the one question where data comes from. Different data generates in the world. There are so many sources from where we can get the data, like Facebook, Twitter, Gmail. The quantity of data on planet Earth is growing exponentially for many reasons. Various sources and our day-to-day activities generated lots of data. With invent of the web, the whole world has gone online. Every single thing we do leaves a digital trace. With the smart objects going online, the data growth rate has increased rapidly. The major source of big data are social media sites, sensor networks, digital images, so many, etc. So, this is different data generators in the world: sensors, CC cameras, social networks, online shopping, airlines, national climate data center, hospitality data, New York Stock Exchange. There are so many sources. Next is how to store big data. Analyzing your data characteristics, selecting data sources from analysis, eliminating redundant data, establishing the role of SQL. Now, there are many sources from we get data. So, example of big data, daily we upload millions of bytes of data. 90% of the world's data has been created in last 2 years. Walmart handles more than 1 million customers. This is so example. There is so examples of big data increases exponentially. Walmart handles more than 1 million customers transactions every hour. Facebook stores, accesses and analyzes 30 plus petabytes of user generated data. 230 plus millions of tweets are created every day. More than 5 billion people are calling, testing, tweeting and browsing on mobile phones worldwide. YouTube users upload 48 hours of new videos every minute of the day. Amazon handles 15 million customers click stream user data per day to recommend products. 294 billion emails are sent every day. Services analyzes this data to find the spams. Modern cars have close to 100 sensors which monitors fuels levels, tire pressure, etc. Each vehicle generates a lot of sensor data. There is something about risk of storing big data. Will be so we'll need to right people and solve the right problems. Cost accelerate too fast. It's necessary to capture 100% data. Many sources of big data is privacy. Some data needs privacy. Some data self-regulation. Some data is collected from self-regulation and legal regulations. So, we can say that there are some applications of big data. We cannot talk about data without talking about the people who are getting benefited by big data applications. Almost all the industries today are leveraging big data applications in one or the other way. Next is why to store data. Making use of petabytes of patients' data, the organizations can extract meaningful information and then build application that can predict the patient's deteriorating conditions in advance. In case of telecom sensors collect information, analyzes it and provide solution to different problems. By using big data applications, telecom companies have been able to significantly reduce data packets loss, which occur when networks are overloaded, and thus providing a seamless connection to their customers. Data dictates the fate of company because any business company do some meaningful analysis for or further estimates about the projects. Data analysis is important to business. This is the diagram of huge volume of data, and this is storage of big data, and this is the form where data comes from, and here stores all the data in the form of big data. There is now we can say that there are, as I already discussed, there are many sources from where we can get data, and we need to store that data in some particular place. So, in the case of retail has some of the tightest margins and is one of the greatest beneficiaries of big data. The beauty of using big data in retail is to understand customer behavior. Amazon's recommendation engine provides suggestions based on the browsing history of the customer. There are some examples like traffic control. When we occur in traffic congestion, traffic congestion basically is a major challenge from many cities globally. Effective use of data and sensors will be a key to managing traffic better as cities become increasingly densely populated. Next is manufacturing. Analyzing big data in the manufacturing industry can reduce component defects, improve product quality, increase efficiency, and save time and money. In the case of search quality, every time we are extracting information from Google, we are simultaneously generating data for it. Google stored this data and uses it to improve its search quality. So, we can say drawbacks or challenges with big data. Let me tell you a few challenges which come along with big data. The first is data quality. The problem here is the fourth V, that is veracity. The data here is very messy, inconsistent and incomplete. Dirty data costs $600 billion to the companies every year in the United States. So next is discovery. Finding insights of big data is like finding a needle in a haystack. Analyzing petabytes of data using extremely powerful algorithms to find patterns and insight are very difficult. Next, in the case of storage, the more data and organizations has, the more complex the problems of managing it can become. The question that arises here is where to store it. We need to store system which can easily scale up or scale down on demand. So, basically there are some challenges in big data, that is data quality, discovery, storage, and sometimes we can also talk about security. Since the data is huge in size, keeping it secure is another challenge. It includes user authentication, restriction access based on a user recording data access, histories, proper use of data encryption, etc. We can also say there is one challenge also, lacks of talent. There are a lot of big data projects in major organizations, but a sophisticated team to developers, data scientists and analysts who also have sufficient amount of domain knowledge is still a challenge. So, basically there are some challenges in big data, that is data quality, discovery, storage, security, analytics and lack of talent. This is big data, challenges of big data. data acquisition, information search and analytics, high volume of data, high velocity of processed data, information storage and analytics, data security and privacy, high variety of information and high veracity of data. So, how to overcome these challenges? The problem, there is some problem we discuss about. Data is too big to store on one machine. So, what is the solution of this problem? Store the data on multiple machines. We can store our data in multiple machines. Next, very high end mechanisms are too expensive, runs on commodity hardware. Problem 3, commodity hardware will fail. If commodity hardware will fail, so then what will do? Software is intelligent enough to handle hardware failure. Next is, what happens to the data if the machine stores the data fails? Replicate the data. As I already discussed in the case when I taught cloud computing security model, I taught that there are so many cloud providers which provide the facility of cloud computing, and there are so many clouds. If one cloud is crashed, our data still secure in another cloud. How can distributed machines organize the data in a coordinated way? That is master-slave architecture. Big data storage is challenging. Data volumes are massive. Reliability of storing petabytes of data is challenging. All kinds of failures, disk, hardware, network failures, probability of failures simply increase with the number of machines. This is some analysis of big data, that big data is more real time in nature and traditional DW applications. Traditional DW architecture, example Exadata, Teradata are not well suited. Shared nothing massively parallel processing scale out architecture are well suited for big data apps. Or we can say this is simple graph of accelerating time to value. We can see how data increases day by day, how data increases day by day, like data available can sometimes get messy or maybe difficult to trust. This is some applications of data analytics, smarter healthcare with the help of big data, smarter healthcare, homeland security, traffic control, manufacturing, multi-channel sales, telecom, traditional analytics. So, we see that big data is term used for collection of data sets that are large and complex, which is difficult to store and process using available. Or in all these cases, data sets are that are too large and complex, which is difficult to store and process using available database management system tools or traditional data processing applications. The challenges include capturing, curating, storing, searching, sharing, transferring, analyzing and visualization of this data parts. So, this is applications of some applications of big data. What is big data in the real world? Log storage in IT industries. In IT industry, there are so many amount of storage are needed. So, this is log storage, IT industries and sensors data. Massive amount of sensor data is also a big challenges for big data. This is all for big data. Thank you so much.